Good morning, everyone. Brad Baker here again with the Ontario Bat Network. For the new folks that we haven't seen yet, the Ontario Bat Network is a relatively new organization stemming from the second Ontario Bat meeting hosted by Toronto Zoo in 2019. Following the 2019 meeting, and before we really knew what was about to come at us with COVID, we came together in an effort to ensure that the third Ontario Bat meeting happened. Well, here we are now with our speaker series in an attempt to get current research and bat work out to the broader Ontario community under the current COVID restrictions. Michelle Curran, who is also part of the Ontario Bat Network, will introduce our presenters.
Hi, everyone. I'm really pleased to present Tessa Anderson and Michelle Nieroda as our speakers today. Michelle and Tessa are graduate students from the Ecosystem Restoration course at Niagara College. As their field project, they carried out the project that they're going to be presenting to us today. They basically carried out the project as a mock contract in which Landcare Niagara was the client. Landcare Niagara is a not-for-profit environmental stewardship organization. And one of their current projects is focusing on species at risk bats in the Niagara region. So the modeling and mapping carried out by Michelle and Tessa is the important first step to allowing this project to begin surveying and documenting rock features in Niagara as potential species at risk bat habitat. If anyone's interested to follow the progress of this project going forward, it's all going to be documented on Landcare social media platforms and also their website and their newsletters. I've had the pleasure to work directly with this dynamic duo. I know you will all be really supportive today and looking forward to hearing about their project. So let me pass it over to Tessa and Michelle. Welcome.
Thank you, Michelle. Good morning, everyone. My name is Tessa Anderson and my partner here is Michelle Nieroda. Today we're going to be discussing our project on mapping hibernacula and roosting locations of bat species at risk within the Niagara region. So to start things off, we're going to start off with a little run through of our agenda. And I'm sure many of you are likely familiar, but we're going to begin with a brief introduction of our 4 bat species at risk here in the area. Next, we'll lay out some background information on the project, and following that, we're going to look into the steps we took in creating our suitability maps.
All right, so there are 4 species of endangered bats in Ontario. We have the little brown myotis, the northern long-eared myotis, the tri-colored bat, and the eastern small-footed myotis. Unfortunately, human disturbance and the white nose syndrome are the primary reasons for decline in these populations. Therefore, determining potential roosting and hibernacula locations is essential for successful conservational efforts. However, currently the Niagara region lacks a comprehensive and organized resource for identifying current and potential bat species at risk hibernacula and roosting locations.
So as a result, we have conducted a landscape level analysis to map the presence of suitable bat habitats within the Niagara region. The project design was to create 2 maps. The first map displaying suitable hibernacula for all 4 bat species at risk, and the second map displaying suitable summer roosting habitat for the eastern small-footed myotis. Compared to the species overwintering biology, the summer activities are relatively unknown. So with all these potential sites identified through our analysis, Landcare Niagara is now able to conduct preliminary visual surveys for potential bat species at risk, roosting and hibernaculum locations, and eventually they will conduct acoustic monitoring as well as swarming and exit surveys.
So the following images display the types of bat habitats we're looking for in this study. We're specifically focusing on natural features, so rocky features, as well as adequate forest cover. Now, for our study, we used a weighted overlay analysis in ArcMap. This method uses a numerical weighting factor that assigns each layer or each data a value according to its relative importance compared to all other layers or all other data. In order to combine the criteria from the different data sources, each layer was reclassified into a common scale. So as shown in the image to the right, both boxes have been reclassified to a common 1 to 3 scale. And only then can they actually be combined. Now, the first box has a greater influence than the second box, so therefore it will influence the final product the most. For our two maps. We use a scale of 1 to 4, with 4 representing the best suitable hibernaculum and roosting locations, and 1 representing the least suitable hibernaculum and roosting locations. So what are hibernacula? In the autumn, when the temperatures begin to drop and food resources become scarce, the bats prepare to hibernate for the winter. They accumulate a large supply of fat that becomes their food reserve during the months of October to April. Hibernacula are cool and humid locations, such as caves and abandoned mines, in which the bats overwinter in by entering a state of torpor. Bats enter this torpid state by decreasing their metabolic and heart rates and by dropping their body temperatures from 36 degrees Celsius to match the surrounding environmental temperatures, which can be as low as 3 to 6 Celsius. As a result, they require high levels of humidity in order to prevent dehydration, and these areas chosen must have low light and low noise levels. For our 4 bat species at risk, the most important criteria chosen for hibernaculum are 1, they need to have the presence of rocky features. So we have talus slopes, cliffs, caves, and rock crevices, as well as 2, the land cover surrounding these rocky features need to be suitable. According to our literature review, bats tend to prefer forest cover. Areas on the map that were restricted or excluded from our analysis include urban areas, because even though bats use anthropogenic structures to hibernate, our project did just solely focus on natural features. And of course, water bodies were restricted because bats don't roost in the middle of water. All right, so now on to what layers or what data did we use to reclassify and then combine for our weighted overlay. Karst Topography is our first layer, and Karst Topography is shaped by the dissolution of carbonate rock, such as limestone and dolomite. It's characterized by sinkholes, underground rivers, and cave systems, indicating potential bat habitat. Now, the Niagara escarpment, which is shown in the green line above, and the Onondaga escarpment shown in the bottom green line are examples of landforms that are influenced by karstification. Areas of known karst topography were weighted the highest of 4 because they are based on published data and or field observations, and they have the highest potential to have actual suitable rocky features that the bats require for hibernating. Inferred regions are areas that were highlighted with carbonate bedrock that are most susceptible to karstification, and they received a score of 3 because they are likely to have these rocky features. Potential regions are areas of carbonate rock units, which are identified as susceptible to karst processes, and they receive a score of 2 because they have a potential for having these rocky features. And of course, all other areas receive a score of 1 because it was assumed that these regions don't contain these rocky features or are very unlikely to contain these rocky features. Now on to the next layer that we used and reclassified. It was the Southern Ontario Land Resource Information System, or Solaris for short, and it's based on the ecological land classification for Southern Ontario. Now, opened and treed cliffs, talus slopes, and forests were rated the highest of 4, as a majority of the Niagara escarpment and then Onondaga escarpment, where these rocky features are present, are in forested areas. And in addition, forest cover is preferred among bat species, especially those who choose hibernacula close to maternity sites. Plantation, tilled areas, extraction sites were weighted the lowest of 1 because these areas are less natural. And then beaches, sand dunes, tall grass prairies, bogs, thicket swamps, and marshes were weighted at 2 because they're unlikely areas for hibernaculum or even to have a lot of rocky features. Treed swamps received a score of 3 because they do have that forest cover and maybe a potential for rocky features if they're found on karst topography. Now, continuing from the Solaris land use layer, as a requirement for our ecosystem restoration program, we also developed a student engagement activity. So we had a ground truthing study that was undertaken by our classmates in our ecosystem restoration program. Student teams are directed to various locations along the Bruce Trail to essentially ground truth and establish confidence in this Solaris layer that we were using for our analysis. Locations were selected based on geological features such as known karst topography, as well as the cliff and talus land cover that was based on the Solaris land use layer. The results of the ground truthing study do in fact show that the Solaris layer is accurate in portraying the location of these talus and cliffs where the students were sent. Although when I was individually examining the Solaris layer, cliffs and taluses were not completely documented throughout the Niagara region, and it's something that should be considered when actually using this layer. All right, so now back to our first map where we have reclassified our karst topography and our Solaris land use layers. The chosen weights or influence for each layer were karst 60% and land use 40%. And this was done following Landcare's Niagara's instructions to focus on those geological rocky features. So there we go. Here are our final map products for map number 1. For our 4 species at risk bat hibernaculum. So the most suitable areas are shown in pink, and in this northwestern section of the Niagara region, they can be found along the northern portion of the Niagara escarpment within the municipalities of Grimsby and Lincoln, and a little bit in West Lincoln. Here in the northeastern region of our study area, suitable habitat can be still found along the Niagara escarpment, but now we have some suitable habitat also along the Niagara Gorge. And in the south, hibernacula can be found along the Lake Erie coastline in the municipalities of Port Colborne and Fort Erie, consisting of primary karst topography associated with the Onondaga escarpment.
So now moving on to the eastern small-footed myotis, which I will probably refer to interchangeably as the small-footed bat. It is the smallest bat species in Ontario and is often found near deciduous or coniferous forests, as well as open farmland. During the summer months, you might find these bats in buildings, under bridges, under rocks, rocky outcrops, mines, hollow trees, and caves, with females in particular roosting close to water sources. So since our client, Landcare Niagara, was only interested in natural features for this project, forested habitats near water with rocky topography and talus slopes became our primary focus for mapping potential roosting locations. And as mentioned, this project, Landcare Niagara, was only interested in natural features. So for urban areas, they were restricted from our analysis, as Michelle has mentioned, as well as water bodies, as these animals are not roosting in the middle of these areas. Moving on to our roosting criteria. It is a lot like our Hibernaculum criteria, but we also added high solar exposure and proximity to water as 2 of our weight classes. Specifically, we're prioritizing southern aspects due to the species' preference for increased solar exposure, which is found on southern aspects. Additionally, we included proximity to water because reproductive females have been found to drink up to 14 times more water than non-reproductive adults. Additionally, these areas are prime locations for hunting and feeding on insects. So our land use reclassification also looks a lot like our Hibernaculum land use criteria. However, we weighted thicket swamps, bogs, and marshes up a weight class onto level 3. They received a more suitable score as the female small-footed myotis prefers to roost near water bodies, which is not the case for our hibernaculum location. So that just opens things up a little bit in that regard. Moving on to our karst reclassification, it is the same as our hibernaculum karst weights in that known and inferred locations were rated the highest, and they're mainly found along the Onondaga Formation and Niagara Escarpment, which is highlighted in this slide here. So moving on to aspect, this criteria was reclassified from a digital elevation model into the values you see here, following our common 1-to-4 weighted scale that we've already used for our land use and karst layers. So southern aspects, including the southeast and southwest, were scored with a 4, as the eastern small-footed bat prefers high solar exposure. Therefore, southern facing slopes are the most suitable. On the opposite side of the scale, we have north, which was reclassified as least suitable given the score of 1. Flat areas were scored a level 2, as there is evidence of rocky roosts being found on flat rock barrens. We scored east and west with a somewhat suitable 3 due to their proximity to the south. And our final criterion for our roosting map is proximity to water courses. So using our Euclidean distance tool in ArcGIS, 4 categories were created and ranked by suitability on our common 1 to 4 scale. As discussed earlier, we know that this species is likely to exist near water, so we essentially weighted distances as the closer the better. So now we've got land use, karst, aspect, and proximity to water all on a common scale, and we are ready for the weighted overlay. So just to review, the weighted overlay was used for the roosting map to combine the reclassified layers. We did touch base with bat experts and were recommended to weight our layers more evenly than we initially proposed. So we also grouped these layers together, resulting with karst and aspect weighted together with 30% influence, and they represent rocky features and high solar exposure. Our land cover and proximity to stream layers were grouped together and were weighted with an influence of 20%. So with all these skills programmed into ArcGIS, along with our restrictions, we were able to run the weighted overlay, and we got a map that looks like this. So here's our first inset of the final roosting map. We've zoomed in on some pink areas which represent the suitable habitat, and you can see quite a bit is here in the Grimsby and Lincoln area. If you're familiar with the Niagara escarpment at all, or the area, you're probably not super surprised by this because there's quite a few conservation areas along the stretch of the peninsula and the escarpment. Moving along, here's another area within our roosting habitat suitability map. Our digital elevation model is showing here the lower elevations in red. This provides a visual where our escarpment boundaries lie and how this relates to our suitable roosting habitat. There are also some isolated patches in Lincoln and Pelham here. If you look towards the bottom of the slide, they are primarily sticking close to watercourses as well as the escarpment. So over to the Lake Erie side of the peninsula. Based on our analysis, the most highly concentrated areas of roosting suitability in the entire Niagara region can be found in the Wainfleet and Port Colborne area, following the Onondaga Formation. So this final map slide here is showing the southeastern portion of the Niagara Peninsula, where we see a continuation of suitable roosting habitat. It is likely continuing further east into New York State following the Onondaga Formation.
All right, and then in terms of future recommendations for mapping, we suggest that a fuzzy analysis for the suitable hibernaculum and roosting locations of the species at risk bats may be more suitable than a weighted overlay, as the bats' decision-making process is probably a lot more complex than just the criteria we outlined in this presentation. And the weighted overlay provides a more of a rigid yes or no comparative approach. In addition, a sensitivity and error analysis for each map were not completed due to time constraints, and that may have provided a more robust and reliable maps, and that's something that should be considered in the future. And finally, these maps are just our initial work. We are still waiting to hear back from bat experts, and we are willing to change our reclassification and our weights to provide higher quality and more accurate maps.
So just to summarize, following our spatial analysis, the most suitable hibernacula for all 4 bat species at risk within Southern Ontario can be found along the northern portions of the Niagara Escarpment, most notably in Grimsby and Lincoln. For summer roosting habitat, the most concentrated areas are in the southern portion of the study area along the Onondaga Formation, specifically in the township of Wainfleet. As with our Hibernaculum map, our summer roosting habitat map also identified areas in the northern section of the study area in Grimsby and Lincoln as well. So just before we wrap things up here, I just wanted to say a quick thank you on behalf of Michelle Nieroda and myself. We know it's a super busy time of year for everybody, so we really appreciate having the opportunity to present our project to you all. If you have any questions, please do not hesitate to ask or pop them in the chat. Thank you so much.
Thank you, Michelle and Tessa. That was a great presentation. We have one question so far from Derek. I'll let him pop on and ask that. And yeah, I'd encourage anybody else who has questions to pop them into the chat. This is a pretty interesting presentation, and I think that there's some great work being done. Derek?
Yeah, so first of all, that's great work that you're doing. It's really impressive to see being able to overlay those. And it is challenging because the little bits that we know about bats, we're trying to use those to make decisions, and you're doing a good job trying to overlay all those things. I think you're perfectly. There probably is more complexity to it, and but this is a great place to start. My comment is more of just a comment than a question, but bats also use man-made features a lot, and in particularly underground tunnels probably are used for hibernation. I just wondered if you thought about including some ways to include those in your analysis and direction for future.
So I think that's definitely something that we should include in future analysis, but we were just working off of a preliminary framework for identifying natural features, because once we start adding in all the anthropogenic sites, it just really opens things up a lot more, and it might overwhelm possible survey areas.
Yeah, and of course it'd be you would need to find just data that's available that actually highlights these specific structures, because if we were just to include like all urban areas, I think the whole map would just be highlighted in pink. So it's definitely not only just we got to consider those anthropogenic structures, but we also have to consider if there's data available that actually differentiates those structures and not other things that we don't want to include.
I agree, and that's challenging. I've tried. Sites in Niagara. I grew up in Niagara, so I know the area really well. One thing I'll point out that might be just an option to add is the potential. For example, the Aramosa Karst, which you had highlighted in one of those, fantastic underground tunnels. Cavers love to explore them, but they feel like completely filled with water. So as much as they would be awesome from a lot of ways, because of their likelihood to flood, not suitable for bat hibernation. And it's going to be hard to characterize that. So I'm giving you another challenge that might not be easy, but it's just something else to think about. Is one issue with a lot of underground spaces.
Thank you.
I was curious if you looked at, you talked about adding the water layers to the second data set. And I was wondering if you looked at, and number one, you said it was just water courses. So I was wondering if you looked at the topography associated with those water courses and the slopes. And I also was wondering if you included any data associated with ponds and vernal pools. Just because I know that those are well used by some of these bats when they come out of their roosts or overwintering habitat. So I was just wondering if that was characterized in your data.
So it was not. We did have a bit of a struggle finding GIS layers. So there is kind of a constraint there. It definitely would have been nice to include vernal pools and that sort of thing, but we did not, unfortunately.
It's probably something we can add in the future. Do a little more hunting for those layers and add them. I know that the watercourse data did include like lakes and bigger water bodies as well,
and bogs.
Yeah. So there definitely was some. We had some data to work with. But it would have been good to, for sure, if there's data available for known vernal pools or smaller bodies of water, we should definitely add that.
Excellent.
I'm sorry, it's Michelle Karam here. And just to add to that, I think the students are also not highlighting, they're being quite humble in the fact that they had to do this project within a couple of months. So I should just bring that up because I don't think that they've highlighted that themselves. So it was quite a short time span that they did the project within. And yeah, we were definitely on Landcare Niagara's part, it was definitely a first step to see where we should actually go start looking. But all the information that everyone's bringing up is really fantastic because we can note all this down and then work further on these models and perhaps make them even more complex.
And
So that's really great. Yeah.
They've done a fantastic job. I think everyone agrees that it's a great starting point.
Thank you.
So,
yeah, we really want to highlight that they're preliminary maps.
well, we got to start somewhere, right?
Exactly.
So,
absolutely, that's great.
Do we have any other questions? We can even go to raising hands if people have questions that they're too shy to type into chat. Otherwise, I think I would just like to thank you both for coming out and presenting. This has been great. I can't say that enough. And yeah, we look forward to seeing what else comes out of this, Tessa and Michelle. Thank you so much.
Awesome, thank you. So do we. Thanks for
having us. I should mention, if anyone wants any contact information, I'm going to put it into the chat at the moment. If anyone wants to ask any questions about the project going forward or the project that you've seen today, you can use all of these methods of contact that I've just put into the chat now. So if anybody's interested, you can keep up with the project.